Hey, mechanical systems design. Good to see ya. I guess it's almost over here, all but for the celebration. And it has been a quarter. We've come a long ways, and I just wanted to record this quick video just to remind you of how far we've come. So, if you remember back to January, just 10 short weeks ago, most of us had not used 3D printers before, let alone assembled and tuned our very own printer. And it was at the beginning, especially, there's some frustration to that. Bed leveling. But by now, most of us are really quite good with these tools. You know how to design parts for 3D printing, how to analyze typical kinds of shapes that you'll 3D print, slice them, print them, and then use those parts. And this is really an amazing tool that you now have in your back pocket for the rest of your careers. You take good care of that printer, and it'll remain an awesome tool for design for you for years to come. If we think back to January, most of us also had not done any finite element analysis. And if we look at the way our FEA has evolved from that first project to this last project, you all have come a long ways here. Thinking about how to constrain single components to most accurately capture what they'll experience in the real world, using FEA sketches to making these full assembly analyses to get accurate estimates of stress in complicated systems. This is another amazing new tool in your toolbox. And of course, most of us coming into this class had very little exposure to electric motors. And I know for some of us at the beginning, that was a little bit, a little scary, all those equations, but we all worked through it. And by the end, we're able to pick voltage and gear ratio so as we maximize power from a motor and avoid overheating. That's pretty impressive. I mean, motors they're all around us. They're in tons of different mechanical systems and products. And now we'll understand how they work and how to incorporate them into new designs, which is pretty cool. And of course, this has been the first deep experience for most of us in short form technical writing. And probably for most of us before this quarter, we didn't think about writing as a way of thinking through something and improving our own understanding of it, or using writing for design to make our designs better. But based on those summary pages I've been reading, you all have come just light years from the second week of the class. And that's another skill that is going to serve you really well. You're going to be able to convince your peers and supervisors, funders and clients that your designs are great in very few words. And that's going to come in handy. And of course, we have gone deep on an approach to design that incorporates ideation, simple theoretical models, computational tools, prototyping, and iteration in that creative design process. And we've especially gone deep on our understanding of the power of models for design. So at this point in the process, it's pretty clear that armed with just a few simple universal rules, we can do amazing things. For example, if we just focus on the concept of static equilibrium, we can perform free body diagram analyses to understand how a component is loaded and how that loading interacts with its shape. But we can also understand why gears amplify torque, or why triangles are strong, or how to put, more broadly, connect a bunch of parts together in a strong assembly, or why a smaller shaft will result in lower energy loss due to bearing friction. If we add a few more models in there, like of stress and buckling, we can now see how the geometry of a component connects it to failure and invert that in order to design really mass efficient shapes. If we add in electromechanical and thermal models of motors, we can make tiny robots that put out a lot of power. And so through this experience, we've seen that these models are incredibly powerful tools for design. And that was why we asked you to take those prerequisite courses. That's why we taught you these things in the first place. And you'll notice we started with things that you already knew, like statics and stress analysis from your solid mechanics course, and energy concepts from physics mechanics course. But we then started to learn and apply some new models, say buckling, electric motors, gears, other catalog parts. And this is how it is in this process. What we're learning is not a set of tools here. It's a broader approach. And what you'll do next is pick up the models that you need for the next context in which you design. So what you should do is notice when you could really use a model that connects outcomes you care about to choices that you get to make. And keep an eye out, especially for generalizable models, things that are always going to be true, that you can add to your collection. And the more you pick up these models, the more you learn, the more impressive the things that you'll be able to design. And this is really a lifelong process. And of course, you'll have an opportunity to go deeper and broader in your capstone design course, where you'll have a lot more time to work on a single design concept. So I have really enjoyed being your lead instructor this quarter. It's been a great experience. It's been really, as I mentioned, fantastic watching you all grow and learn. And I've also enjoyed learning how to teach a little bit better under this remote format. I have been impressed with all of you for different reasons at different times throughout the course. And we always have room to grow, of course, but you should all be proud of how you've done. And I hope you keep in touch. We really like to hear how ME 104 gets incorporated into your internships or your next stage in your career, or ways that we can improve the course, things we should have taught, different ways of thinking about things that could be helpful. Now you'll get one more chance to hang out and celebrate with your coaching group on Friday, but I might not see you for a while. So until then, happy designing.